Hey, this is Mr. Mitchell. Today we're going to be talking about volcanoes. Most of the earth is very, very hot. Now we're not talking so much about the crust as we are about under the crust, like in the mantle. Some of that heat can escape through volcanoes. Now, not just lava comes out of volcanoes. You have rocks that come out of volcanoes and hot gas that comes out of them also. Some eruptions are violent. Some are not so violent, ones that you can even watch from a distance. But how volatile they are depends mostly on the magma or lava coming out of them. Magma high in silica is dense and resists flowing, kind of like oatmeal. Whenever you try to boil oatmeal, the gas gets trapped in and pressure builds, kind of like a volcano like this. Now, volcanoes like this that have the very white lava or ash are ones that are high in silica. You may remember that rocks that were high in silica were lighter. Same thing's true with lava. These are the most dangerous of volcanoes, the ones that are like this. Now, the ones that you see that have all the red, fiery looking lava, they're not quite as destructive. You can see this one is only going 100 or 200 feet high, and then it's just coming down and flowing down the mountain. This is low in silica, and the gas just does not get trapped there. It's the magma is just more watery. Gases escape it just like it does in boiling water. And these, even though they may look dangerous, are just not as dangerous as the other ones. Now you can see off to the side we have some terms. One of the terms is magma chamber. I have this picture here which shows you a little bit about a magma chamber. And you can see the magma chamber down at the bottom here below the volcano. Magma chamber is the area under the ground where lava collects, and it's often underneath the volcano itself. But you can have magma chambers without having a volcano. Sometimes you have magma under the ground and you just don't know it. Let's talk about rock fragments that come out of volcanoes. You have ash, cinders, and blocks. Now, ash, of course, is the size of rice grains or lower. And you may remember this picture here. The most destructive of these volcanoes had a lot of ash coming out of it. And it's often very, very light or white. These can be carried long distances by winds. There have even been volcanoes that have gotten the ash up into the jet stream, and the ash has gone all the way around the world. You have some things that are bigger that come out of volcanoes. You have cinders and you have blocks. Blocks are bigger than cinders. Cinders are kind of in between the two. Now, some blocks can even be the size of houses. Now, the reason why you have these huge blocks coming out is sometimes you have to, in order to have a volcano, you have to burst through the top of the volcano. In this case right here, this is a complete mountain. There is not a hole at the top. So even though this is a volcano and it doesn't have a hole at the top, if it were to erupt, it would erupt through the top here, and all that ground there would have to shoot out somewhere. And that's exactly what would happen. Sometimes you have these big blocks of ground and rock that actually come out during a volcanic eruption. Okay, let's talk about probably the most dangerous part of a volcanic eruption is the pyroclastic flow. Pyroclastic flow is the super hot volcanic gases and rock fragments that race downhill once you have an eruption. Here is an example of a pyroclastic flow. You can see here you have the volcano erupting, and you have all the hot gases running down the side of this volcano. Now, these hot gases are just going to be more than people can stand. It can get up to 1,500 degrees. And you can imagine anything that gets caught in a pyroclastic flow is not going to survive. And it can travel up to 100 miles per hour down the mountain. Have kind of an interesting picture here. I don't know if you can see it very well, but we have this pyroclastic flow coming down the mountain, and there's a Jeep right there trying to outrun it. And I don't know if they made it or not. I'm assuming they did, or we probably would have heard about it. Let's see, where did we get to? Volcanoes are common along tectonic plate boundaries where you have subduction. Now you may remember that subduction is when you have one tectonic plate buckling up under another. And that's what's happening here on these plates here along the western coast of the United States. And it's happening also all along this ring of fire. That's where you find 80% of all the volcanoes in the world. And it happens when you have those plates buckling up under the other plate. The friction just seems to cause volcanoes there. Now some volcanoes form at hot spots, but 80% of them come around this ring of fire. Now let's talk about three different kinds of volcanoes. You can see shield volcanoes, cinder cone volcanoes, and composite volcanoes. Here is an example of a shield volcano. Now this shield volcano here is very flat. You can see that it doesn't quite look like a volcano often would. It's very flattened out. This shield volcano, these are going to be low in silica. Now what happens whenever you have that lava coming out, it doesn't go very high, it just kind of goes down the mountain and they end up forming rock, and that's how these form. Now Hawaii has shield volcanoes. Some of the less dangerous volcanoes are shield volcanoes. There's another kind of volcano that you don't find as often. They're cinder cone volcanoes, and they are not terribly dangerous. Cinder cone volcanoes look like this. In fact, they're very symmetrical. You can see an example of one here. These are small. They're usually not the biggest volcanoes around. Lava melts as it erupts, and as it comes up through here, it actually cools and falls out. That's why you have this little cylindrical area there. Now these usually are around other volcanoes. Look off in the distance here. You can see some smoke coming from up here. I suspect this is the big volcano, and this is just a little bitty area where lava happens to be able to creep up, and that's what you find often with cinder cones. So we haven't really been over an explosive, violent volcano yet, but we are here. The composite volcanoes are the ones that do the mass amount of damage. We've already seen this picture, but see how this is different from the other two? The shield volcano is much flatter. This is a composite volcano. They really do have that stretched upward volcano type look. These are ones that are high in silica. These are the ones that will have the volatile ashes coming out, the ones that would have the pyroclastic flows, and the rock must be blown out the top of these. They must be blown out the top of these before magma can erupt. Now these other two, they have the holes already in them. And I don't have it over here, but the holes in the top of these other volcanoes are called caldera. I believe this one probably would have a better looking one. So this area right here is called a caldera. And I think on the Science Seekers video, they mentioned some caldera on Hawaii, which would be a shield volcano. Now, good news about volcanoes. Volcanoes are easier to predict when they're going to erupt than earthquakes are. There are warning signs about volcanoes. Small earthquakes, steam coming from the calderas, rising ground temperatures. So it's much easier to predict volcanoes. Now, there are some characteristics about volcanoes. Lava from volcanoes, even though they're igneous rock, over lots of time can actually produce very fertile soil. Many times all these valleys that have been scarred in years past to volcanic activity actually have magnificent landscapes. So you tend to have a lot of cities around volcanoes, and part of that is because it's around the Pacific. I mean, you're going to have cities around the Pacific Ocean. So there are some big dangers that come with being near volcanoes. Now, some of them are predictable. You have mud flows that we've talked about before, and there'll be rock slides sometimes. There we talked about the pyroclastic flows, which can actually reduce a city to rubble. But other things we need to talk about are the effects of ash and the lava flow itself. Now, most lava flow is it's pretty slow actually. Most lava flows are slow, but still it's going to be hundreds of degrees, even into the thousands of degrees, and it's going to be very hot. So do not ever get into the path of a lava flow, even if it is very slow. Now, the big ash that comes out of some of these volcanoes, that is made of tiny pieces of rock, and that's why the ash that comes from volcanoes is often very heavy. Now, I have here a picture of some cars with volcanic ash on it. This was in a volcano in 1991, and many times if you get more ash than that, then it actually can cave in the roof of cars and cave in the roof of buildings. Volcanoes tend to smell like rotten eggs. The gases mixture with the water and the air make acid rain, and they tend to smell like rotten eggs, especially if they are active. An ash from Mount St. Helens eruption blocked so much sunlight after that eruption in 1980 that street lamps were turned on in many nearby towns because it literally looked like it was nighttime. Now, a couple other things we need to talk about: hot springs, geysers, and fumaroles. Now, hot springs are where magma is close to the surface, but it's not at the surface. And if you have a magma chamber that's close to the surface, if you have any water that happens to be moving near it, it's gonna get it very hot. And that's where you get hot springs from, because it happens to get close to that magma. Now, a type of hot spring is a geyser. Now, we have a famous geyser in the United States called Old Faithful. I think this actually is a picture of that. Now, what happens is you have this magma chamber underneath the ground. The water gets close to it, and you know what happens with hot water? It kind of has a tendency to boil and bubble and shoot up. And I think this geyser is predictable up to every 35 minutes to 2 hours. It is going to erupt, you might say. Now, this is not going to hurt anybody, but it's just water that shoots up, and that is a type of hot spring. Now, something very similar is called a fumarole, and I'm going to show you a fumarole here, but you'll see the difference in them. They look, I mean, this is a fumarole right here. This is just like a geyser, except this is steam. This is steam, and it's just like a fumarole. It's just like a geyser that is not pure water. It's just water and air. It is steam.